All right, last lesson we talked about slope and we were able to determine slope from a graph, a table, or two ordered pairs. Now we're going to focus on slope-intercept form of an equation of a line. And our slope-intercept form is y equals mx plus b. Hopefully we recognize m. M is still our slope. So then b represents my y-intercept. And my y-intercept will always be in the form of 0, comma b. So why is this called slope-intercept form? Well, what two things does it give me? It gives me the slope and it gives me the y-intercept. Now our linear function of a line, instead of y equals, we have f of x equals. So f of x equals mx plus b. The two important things are the exact same thing. My m is my slope, and b is my y-intercept in the form 0, comma b. So what does this here tell me? Something important going through for honestly the rest of the course is that y and f of x mean the exact same thing. And let's even give that a highlight here. Y and f of x mean the exact same thing. So we need to keep that in mind as we go throughout this entire class. So example 2, determine the slope and the y-intercept of the linear function g of x equals negative 3x plus 1, and then graph. So what is the slope? Well, my slope is whatever is in front of the x. Notice slope is just m. It is not mx, right? So what's in front of x is that negative 3. So my slope is negative 3. Now we're going to end up graphing this, right? So we need to put this as a fraction so we know our rise over run. How do we turn negative 3 into a fraction? That's the same as negative 3 over 1. And then what is my y-intercept? My y-intercept is whatever doesn't have that x. So it is this 1. So if I put this as an ordered pair, this is 0, comma 1. Whatever this number is, that b is my y-intercept that goes in place of my y-coordinate. So let's graph this. When we graph, we always start right here at this y-intercept. So we have 0, 1. There is my y-intercept. And now use your slope. If I have negative 3 over 1, that's the same as going down 3 and to the right 1. So from this point, I'll go down 1, 2, 3, and to the right 1. Technically, to graph a line, this is all we need, right? We need two ordered pairs, put the ruler, connect them, draw your line. I'm going to go the entire graph paper though, to make it as accurate as possible. So from this point, because slope is also called constant rate of change, I know I can keep doing this the entire way. So we'll go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, and I don't have 3 to go down anymore. Again, this is enough to graph my line, but I'm going to go one step further. I'm going to go in the opposite direction. So the opposite, instead of going down 3, we'll go up 3. And instead of going to the right one, we'll go to the left one. So from this starting point right here of that y-intercept, I'm going to go up 1, 2, 3, left 1, up 1, 2, 3, left 1, and up 1, 2, 3, left 1. Now I will connect my lines or my points. And then when we graph these, we need arrows on the ends because this graph continues on infinitely in both directions. It does not start and stop on this grid paper. So is the slope increasing, decreasing, or constant? Hopefully we can see that this one is decreasing. Okay, 1 going down as you go from left to right, and simply my slope is negative. Example 2 says find the slope and the y-intercept of the line and then graph. So same instructions really, but what's the problem with this equation right here? Okay, hopefully you noticed that it is not in this form. So we need to put it into this form here, which means I need to solve this for y. So I'm just going to rewrite this down here. Okay, so let's get y by itself. So first we need to move this 2x over. The opposite of a positive 2x is a negative 2x. Now, one of the big mistakes that I get right here, especially this early on, as we're kind of knocking off the rust from not having a math class in X amount of years, months, whatever, is that when we come to this right here, we'll put 8x. That is not correct. These are not like terms, so they cannot be combined. Because I want this in mx plus b form, I want my x first. So I'll put negative 2x, and then 10 is positive, so plus 10. But again, this does not become 8x. They are not like terms. Do not combine them. They go side by side. And then lastly, to get y by itself, we'll divide that negative 5 over. What am I dividing by negative 5 on this side? The negative 2x or the 10? Trick question. We're dividing both or everything by negative 5. So those cancel. I'm left with y equals. We've got negative 2 over negative 5. I can't reduce the numbers, but negative over negative does turn to a positive 2 over 5x. And then 10 divided by negative 5 is a negative 2. So now from here, we can answer the 2 questions. It wants us to find the slope. What is my slope here? It is 2 over 5. Slope is whatever is in front of that x. And then what is my y-intercept? Okay, it is this negative 2. We do want to get familiar with writing this as an ordered pair. So this is 0, comma, negative 2. Okay, so now let's graph. When we graph, we always start with that y-intercept. So we're at 0, negative 2 right here. And then use your slope. If it's 2 over 5, rise over run tells me I'm going up 1, 2 and running 1, 2, 3, 4, 5. This is all you need to be able to plot. You can put your line, your ruler right in between and draw your line, but I'm going to go as far as I can in both directions. So we're going to go up 1, 2 over 5 and then go in the opposite direction. We can go down 1, 2 and run 1, 2, 3, 4, 5. Down 1, 2 and then run 5. Here. Is my line. Again, with arrows on both ends because it goes infinitely in both directions. It does not start and stop on this grid paper. And then lastly, is the slope increasing, decreasing, or constant? And hopefully we are good with that increasing. As you go from left to right, this line is going up and also have a positive slope. Now let's do one application problem on the next page. Example 3. It says an annual fixed cost of owning a small sedan is $4,252 assuming the car is completely paid for. The cost to drive the car is approximately 14 cents per mile. We want to write a linear equation that relates to the cost C and the number X of miles driven annually. So we're using, because it even tells me a linear equation. My linear equation is y equals mx plus b. Now, for this specific one, it wants us to write a linear equation that relates to the cost C and the number of X of miles. So I already have my X. It means I need to change my C to a Y, or my Y to a C. Okay, so we have two different numbers here. Excuse me. The annual fixed cost of owning a small sedan is $42.52. And the cost to drive the car is approximately 14 cents per mile. Well, if X is representing the number of miles, that is my slope right there. That is my M. This is a one-time cost. That means I just have to pay it once. It's not dependent on anything. So that's going to be my B. So my linear equation is C equals 0.14x plus 4,252. So then part B wants to know, what is the cost of driving 4,000 annual miles in a given year? We're going to substitute that in for our X. So I'm going to have C equals 0.14 times 4,000 plus 42.52. And my cost is a number. Let's see. And we get 4,812. In general, word problems need word answers, or at the very least units. It wants to know, what is the cost? So this is in the form of money. So my answer is $4,812.